Welcome to Bite-Sized Data Science. The Spark machine learning library started as a library that operated on resilient distributed datasets or RDDs. After the DataFrame API was introduced, a new package called SparkML was introduced. Eventually, the name settled to SparkMLlib, and it included both DataFrame and RDD support. As of Spark 2.0, released in July 2016, the RDD-based APIs have entered maintenance mode and are scheduled to be removed from Spark 3.0. In a previous video, we saw a list of machine learning algorithms. This time, the list represents only the classes related to operations on DataFrames. This is similar to what we saw before with basic statistics, classification and regression, clustering, collaborative filtering, and more. We see, under Other, feature extraction and transformation. This actually is a pretty large set of classes that you will eventually need to be familiar with. In the naive-based video, we talked about document classification. This is where classes like TF-IDF, tokenizer, and stop words remover would be useful, for example. In case you wondered, TF-IDF stands for term frequency, inverse document frequency. Basically, it looks at the set of training documents and looks at the frequency of the words in each document and weighs that to how many documents include each word. This provides a measure of how important a word is in differentiating each document. If a word is found in all the documents, it is not useful in any grouping. The DataFrame API includes another important feature that was not available in the RDD APIs. The pipeline interface. The pipeline interface was mostly inspired from the scikit-learn project. A pipeline chains multiple operations, called transformers and estimators, into a machine learning workflow. This provides multiple benefits. First, it provides encapsulation of the multiple operations or stages that are needed to get to a model. It standardizes the APIs to make it easier to combine multiple algorithms. There is also a performance benefit to pipelines. Since all the operations are grouped into an ordered workflow, there is space for optimization to avoid repeating calculations. Also, the flow of operations allows for parallelism since each member of the workflow can start executing as soon as it gets data as the previous operations works on the new data. Here is an example of a pipeline coming from the Spark documentation. This pipeline transforms raw text and then uses the logistic regression algorithm to create a logistic regression model. We see here that the fit operation operates on the pipeline itself. This is convenient since it is one operation that directs all the stages of the pipeline. The second pipeline here shows the pipeline transform operation that transforms the input data, just like in the previous slide, so we have the proper input for scoring. The result is a prediction from the model. Note that a pipeline represents what's called a directed acyclic graph or DAG. Such a graph always moves forward, never looping back. Note that a DAG does not need to be linear like the example we saw. A pipeline can be saved and restored from persistent storage. The persistence capability works across Scala, Java, and Python. Note that currently in Spark version 2.4, models saved in R can only be loaded back in R. One more thing about persistence. In general, MLlib maintains backward compatibility for persistence. However, when it is between major releases, there is no guaranteed. It is done on a best effort basis. Similarly, a model behavior is maintained between major releases on a best effort basis. Bottom line, if you move to a newer Spark major release, make sure to retest your models. SparkMLlib provides many algorithms to predict, classify, and cluster. If you are using Spark, you must get familiar with these algorithms, but also be aware of all the classes for feature extraction and transformation. Once you are familiar with what Spark offers, you can move on to other machine learning libraries to see if they better fit what you want to accomplish and the skill set of your enterprise. See you next time on Bite-Sized Data Science.